Hi all. So my aim is to I need to create I'm going to create an playlist for wheelchair. So what are all the ways we can control wheelchair? And using OpenCV, I have two methods using face distance and using hand distance from the camera. We can able to move the wheelchair. So in this video, I will show you how to find the playlist, how to find the face distance from the camera. What are all the libraries we need? Um, to settings, then in the project wheelchair gesture, there will be a Python interpreter. I have already on an interpreter. I am using 3.10 Python version. So in this case, I'm using this interpreter for every project. So it is so many. So in this project, I will provide you one requirement.txt file. You can download that. You need OpenCV, CV zone, and media packages to work this project. Uh, Now I'm going to create one new Python file named custom face distance. Put enter. So as a first step, we need to get access to the camera, our local camera. For that, we need to import CV2. Then we need to assign a variable called cap and call video capture. If you are using some external camera, you need to put as one. But I'm using my local disk camera, so it is webcam 0. My computer PC webcam, so it is default webcam, so it is 0. Then inside the while loop, success comma image. So image is the variable I'm going to say read this cap variable. So in the name of image, our video is going to be read. So then I'm going to show in the win name. So win name is nothing but a Windows name in which name it needs to display, and I need to show the image where I have saved this cap. Now we need to call wait key function. So to get delay of 1 here. If it is an image, we will put 0 here, but we are going to operate in video, so it is 1. So now let us check. My laptop is little bit slow, so it is. Yes, it is working well. So next step, we are going to detect our face from the package CV zone. So from CV zone, we are going to get a face mesh module, then import face mesh detector. Next, in the variable of detector, we are going to call face mesh detector, and maximum face, we are going to assign that maximum face it needs to find in frame it's one. So more than one face is find in a frame, it won't be detect. Uh, you can also change that one as 2 or 3, whatever you need. Then faces comma img in the variable image, I need to ask. I'm going to ask that find the face in the image. So image is equal to detector dot find face. Yes. So image. Now let us see. Oh, I'm getting some error. Sorry guys, we just need to interchange this. So before it is like this. So faces comma image, but we need to put as image comma faces. I guess now it will be work fine. Yes, now it is working fine. So now my aim is to find the LM list. I guess the cursor will not visible in the screen record. So just to see that in my left eye and in my right eye there will be a point. So I need to find the midpoint of these both eyes, and I am going to draw a line so that I can find the distance of that both lines. So let us do that now. If faces face of uh, the index point, the index point is 145 and face of 374, it will be faces. So we will assign the variable of face, again face. Instead we can do like this. So face is equal to face of 0. So in the zeroth element, 0 means first element. If we put 1 there, instead 1 there, it will be a second element. So 145 is the left point eye, and 374 is the right point at the right side of the eye. Oh, point right. So next, uh, we will draw a circle. We can mention as draw as false, or else it will be like annoying. If I make draw as false, then before you see one white color dots in my face, it won't come again. So in only the point I have mentioned here, this point left and point I right. So only this point now I'm going to make you visible by a circle, drawing a circle. So in the image I need to draw. So the point left in the radius of on color of 255, 0, 255. Thickness we will make we will fill it CV2 dot fill. So same thing we need to do for left eye. So down we will make it left, and up we will make it as right. Okay, let us see now. Oh, list index out of range. Oh, sorry. Here I need to. So what's the error here? Means I have assigned face as the variable where faces is lying. So here I need to make it as face, not faces. It will be work fine now, I guess. So okay. Yes, this was I told these 2 points in my eyes, middle of the eyes. So next I will draw a line between them. CV dot line, image comma, point 1 is point left and point 2 is point right. Next color 0 comma 255 comma 0. thickness of 3. Okay, now you will see one line in between these two circles. The line will connect the two circles. Our basic concept is when we move forward, that line will visible larger to webcam, so it will assign one distance. And when we go back, now you see. So when I come close to camera, that line will somewhat bigger in pixel size. When I go back, it will assign one distance. So like this, we are going to find distance. 2 points. So the small w is the variable I'm going to assign to find the distance of the 2 point. Uh, Let us call detector dot find distance. Find distance. Point left and point right. We need to mention 2 points. So what 2 points we need to? What are the 2 points we need to find the distance? So point left and point right are the distance we need. Then print w. Let us try this. In this case, when we go forward, it will be increase, and going backward, it will be decrease. You can see now. These are the point. Oh, 2 points are printing. That second we don't need, so we can just say it as none. And let us run again. So only one result we need, not that right side. Only left side path we need. So wait. Let us see now. So when I go closer to the camera, it is showing as 106, 107. So when I go back from camera, far from camera, it is decreasing. But in real time, we need to increase when we come back and decrease when we going in front. So as the next step, we need to find the, let us comment it out, find the focal length. So for finding focal length, I have formula previously. So d is nothing but distance. So what we need to do means, from the 50 centimeter distance from our webcam, we need to sit. So now I take my steel scale or a tape and measure 50 centimeter accurately from my webcam, and I am sitting there. Uh, so f is equal to this small w is this, where the distance between these two points. D is distance, and capital W is something, that object. Here our object is our eye. So for males it is around 6.4, and for females it is around 6.2. So in between value we can take. So 6.3 is the in between value. Uh, Now let us find the focal length value when we sit accurately 50 centimeter from our webcam, and let us see what focal length value we are getting. Let us run that and see. From 50 centimeter I'm sitting, um, it is around 840. So I'm comment this out now. So our motive is to find the distance. So you can see here f equal to small w into d by w. So if we need to find distance means, you can change the formula like f into capital W divided by small w. So you can easily find your distance. So d is equal to f into a w, so capital W divided by small w. focal length we need to define. Now we find this f is equal to 840 as 840. Now let us print d, print d. It is running. So let us see when I come closer to its when I come closer to the camera, it is decreasing as we guess, and when I go back to far from camera, it is increasing. So now we will make it as integer. To make it as integer, you can add as int. Instead printing in terminal, we need to display that result in screen itself. So for that we can use cvzone dot extract as image, comma f distance of we will make integer here, so not here. We can make that also, but it will collapse with the formula. So let us make here then centimeter. So now at which position the result needs to be displayed? So at the position of face of 0th element minus 45, um, comma face of at second position face of same 10 at the first element, not this time not the 0th element, this time with first element. So I forget what to put next, minus 1. So 150. Okay. So here 100 the position, and here 50. So we will keep the scale value as 2. I forgot to mention color, I guess. At which color it needs to be. Let us keep as color as 55, 0, 0 like that. Let us try running this now. Where it needs to display, we will need to define it and mention in bracket. So now it will run. Yes, you can see the distance there. So distance is 121. When I come closer, it is around 60 like that. So this line, so the line, that green line and pink point, you don't need, means you can simply. So here I will just point. If you don't need to draw that point, means you can simply comment this out and let us check now. It will look somewhat clean and neat. Yes, you can see now it is somewhat better. Now as the next step, you need to autonomous some robots using this distance, means you can simply using this distance equals statement, you can do this. only with software, not with hardware. If you need to do this with hardware, means like Raspberry Pi or Arduino, you need to change the code. If D is greater than 75, let us say 75. If my distance from the camera is more than greater than 75, I'm printing robot is moving forward. Let us comment this print function. So if my distance is lesser than 50, then we will say to print as robot is moving backward. So for getting it somewhat attractive than this, we can simply input the TTSX3 for voice assistant. Let us assign the variable engine and initialize PyTTSX3 in it. So then I ask to say as robot forward, and here same like engine dot say robot is backward, robot backward, and engine dot run and wait. So let us try now. So here concept is when my distance of my face is greater than 75 from the webcam, it will print robot is moving forward, and will say as a voice message as robot is forward. And when my distance from the camera is lesser than 50, it will say print as robot is moving backward, and it will say as voice command robot backward. Let us check now. So in between 75 to 50, it won't say anything. It will be neutral. It is running. Yes, you can check now. My distance is currently 65. So I previously I have said if my distance is 50 to 75, in between it won't says anything. So if I get a distance is greater than 75, you can check here robot is moving forward, and it is saying robot forward. So when I go in lesser, when my distance is lesser than 50, it is saying robot is backward. So this is how you can autonomous something using distance. So thank you.